Hello viewers, today in this part of the discussion we will be discussing sequential logic design, and the outline for today's discussion is as follows. First we will start the discussion about state table and state diagram. Then we will discuss about truth table, characteristic table and excitation table, and what is the difference between the three types of table. Then we will move on to state reduction and state assignment. Then we will discuss design procedure for sequential circuit, and then we will discuss the two types of state machine, that is Mealy and Moore state machine, and finally we will discuss clocked sequential circuit. State table and state diagram. For combinational circuit, truth table helps us to simplify the circuit. This we already have discussed thoroughly in our previous lectures. But for sequential circuit, state table helps us in simplifying the circuit. So, the truth table is useful for combinational circuit, whereas the state table is useful for sequential circuit. Now, here in this slide we have shown a block diagram of a operation of a state table. So, here the block diagram shows a sequential circuit which is built from JK flip flop, and here we have shown the input as X, the output as Y, and the corresponding present state and next states are shown from the input and outputs of the JK flip flop. So, here the present states of the JK flip flop is Q1 and Q2, and the next states are represented by QA dagger and QB dagger. Now, let us find out the state diagram for a random state table, that is, let us consider a 2 flip flop system. Now, the 2 flip flop systems will generate 4 states. So, these 4 states can be defined as 0 0, which is shown here as S0, 0 1 which is shown here as S1, 1 0 is shown as S2 and 1 1 which is shown as S3. So, here the state diagram represents each of these states, that is S0, S1, S2 and S3 by a bubble, and the present state and the next states are represented by the track of arrows in the state diagram. Here we have shown the corresponding state table, and from the state table we have also shown the state diagram. Here, as you can see, the state table has 4 columns, and they are present state, input, next state and the output. And for present state, because we have considered 2 flip flops, so we have to consider 2 present states, that is shown here by Q1 and Q2, and the next state is the corresponding values coming from the present states of Q1 and Q2, which is Q1 dagger and Q2 dagger, and finally the input and output column. So, as you can see, the state diagram here shows the 4 states and how the states are changing from one state to the other state depending on the input and output values. Next, we will discuss about 3 different types of table, that is truth table, characteristic table and excitation table. So, here we have shown the 3 types of table by using T flip flop. So, from a T flip flop, the corresponding truth table can have 3 columns, that is one for clock, one for the input from at the T flip flop, and the output which is the next state, which is shown as q n plus 1. So, here as you can see, when the clock is 0, irrespective of what is given at the input of T flip flop, the next state will be the state which was assigned when this input was given. Similarly, when the clock is 1 and the input is 0, the next state is again the same state, and when the clock is 1 and the input is 1, the next state is the complementary state of the input state. So, this represents the truth table. Now, what is characteristic table? So, characteristic table tells us the information about the next state when we know the present state and the input value. So, here when the present state is 0 and the input value is 0, then the next state is the present state only. Similarly, when the present state is 0 and the input value is 1, then the next state is the complementary of the present state. And similarly, the other two conditions are when present state is 1 and input is 0, the next state is the present state, and when the present state is 1, input is 1, the next state is the complementary of present state. Similarly, the excitation table gives us the information about the input that is given to the T flip flop by having the information of present state and next state. So, these 3 tables can be used interchangeably depending on what we are looking from the state diagram. So, when the input is 0, the next state is equal to present state in the truth table, and when t is equal to 1, the next state is the complementary of present state as we saw in the truth table. So, the expression in the characteristic table can be represented in the following way, that is q n plus 1 is equal to q n XOR t, where q n plus 1 represents the next state, q n represents the present state, and t represents the input. Now, let us discuss about state reduction and the assignment of state. So, this is a process to minimize the sequential circuit. Now, let us consider a 3-bit input which can be represented by 8 states, and they can be defined as 0 0 0, which is denoted as A, 0 0 1 denoted as B, 0 1 0 is denoted as C, 0 1 1 is denoted as D, 1 0 0 is denoted as E, 1 0 1 is denoted as F, and 1 1 1 is denoted as G. Now, the state reduction is applied when the next state and the output for 2 present states are same. So, what does it mean? Let us try to understand this thing by considering the following example. So, in this example, we are considering 7 states, and the corresponding state table is shown in this slide, where we have 7 states which are assigned by A, B, C, D till G, and the other 2 columns are representing next state and the output corresponding to the input value of x is equal to 0 and x is equal to 1. And here we have also shown the corresponding state diagram with the 7 states. Now, we want to reduce the state diagram to as much as possible. So, here if we look at the present state E and G, then the next state and output are same, that is A f and 0 1. So, here we can write that E is equal to G and we can eliminate the row for Z. Now, after eliminating, we can see that if we compare D and F, then the next state G f and output 0 1 are same. Hence, we can eliminate F as well. So, we can write D is equal to F. So, after following these steps, we find that the 7 states have been reduced to 5 states and they are A, B, C, D and E. Now, with these 5 states, let us draw the state diagram. So, here in this slide we have shown the state diagram with the 5 states of A, B, C, D and E, and the corresponding migration from one state to another state depending on the input and output conditions are also shown here by using arrows. So, we can say that this method is same as using K map for combinational circuit to get a minimum possible configuration. Now, once we know little bit about these state diagram, state table and the reduction of state diagram, we can now design the procedure for a sequential circuit. So, for that we need to follow certain steps. So, the first step is get the state diagram which describes the circuit that is to be designed, and here we have taken an example of 4 states with their corresponding input and output value and the migration from one state to the other state. And after you get the state diagram, find out the state table from the state diagram, which is very easy. So, here we have 3 columns again: present state, next state and output. Now, the present state, because we have 4 states, so we have 2 flip flop which can be used. So, the 2 flip flop inputs can be QA and QB, and that represents the present state. Now, the next state will be depending on what is the input, whether the input is 0, that is x is equal to 0, or the input is 1, that is x is equal to 1. So, for x is equal to 0, we have 2 next states, that is QA dagger and QB dagger. Similarly, for x is equal to 1, we have 2 next states, that is QA dagger and QB dagger, and we can also have the output for x is equal to 0 and x is equal to 1. So, once we get the state table from the state diagram, check whether the state reduction can be applied or not, and if it can be applied, then one should apply to reduce it further. Here in this example, we can see that it is not applied, and if required, do the state assignment. And what is that? For example, here we can use 0 0 state is equal to A, 0 1 state is equal to B, 1 0 state is equal to C and 1 1 state is equal to D. Once that is assigned, we have to determine the number of flip flops required, and we have to assign those flip flops with symbols. So, here as we said that there are 4 states, so we can use 2 flip flops, and the 2 flip flops can be assigned as the letter A and B. Then once the number of flip flops are known, we have to decide which type of flip flop we need to use. So, here for this example, we are going to use T type flip flop. So, once we have decided the number of flip flops and the type of flip flop, we need to find out the circuit excitation table and state table. So, here we have shown the excitation table in this particular slide, where we have 5 column, and those are the present state column, the input condition, the next state column, then the input to the flip flops, then finally the output conditions. So, if we look at the state table, then we can see for the first state 0 0 with input x is equal to 0, the next state will be 0 0. Similarly, for 0 0 when input is 1, the next state is 0 1, which is the typical kind of information that one can get from the state table. Now, to find out the flip flop input, we have to use the truth table for the corresponding flip flop. So, here we have used T flip flop, and the corresponding truth table is shown in this slide, where we have 3 columns, one is for the clock, one is for the input to the T flip flop, and the other one is the next state of the flip flop. So, here as you can see, when the clock is 0, irrespective of what is the input to the T flip flop, the output is equal to the, or rather the next state is equal to the present state. Similarly, when the clock is 1, input is 0, at that time also next state is equal to present state, but when the clock is 1 and the input is 1, in that case the next state is the complementary state of the present state. And from here we can also find out the excitation table, which is shown in this slide. Now, once we found that out, we have to obtain the expression for circuit output and flip flop input. So, here we have to take help from the K map that we have discussed in our previous discussion. But if we look at the input, that is T A and T B of the flip flop, then there are not many ones in the input. So, we can simply use the Boolean logic to get the output condition or the expression of the output from the two flip flop. So, here for T A is equal to 1, we can obtain the following expression, that is T A is equal to Q A bar Q B x plus Q A Q B bar x. Similarly, for T B is equal to 1, T B is equal to Q A bar dot Q B bar dot x plus Q A Q B dot x bar. So, once we get the two inputs of T A and T B, we can get the final output, which is y is equal to T A plus T B, and if we simplify this, then we will obtain Q A dot Q B bar. So, once we get the expression for the corresponding two inputs at the flip flop, now we can draw the sequential circuit. So, here as you can see, we have considered the two T flip flops which are assigned by A and B, and the inputs and the outputs of the two flip flops are connected to the combinational circuit, which is obtained from the expression discussed in the previous slide. Here you can see the combinational circuit is made out of two AND gate and one OR gate, which is connected via an inverter. And if we use this particular sequential circuit, then we can easily perform the logic that is given at the start of this example. Now, we will discuss two models which are widely used to describe the sequential circuit, and these two models are used for representing synchronous sequential circuit, and they are Moore circuit or Moore state machine, and the other one is Mealy circuit or Mealy state machine. In Moore circuit, the output is a function of present state only, but in case of Mealy circuit, the output is a function of present state as well as the input condition. Both vary in the way the output is generated. So, let us first discuss about the Moore state machine. Now, here in this slide we have shown the simplistic block diagram to represent the Moore state machine. So, here the block diagram is consisting of combinational circuit, flip flop and the sequential circuit. So, here we have shown the combinational circuit, flip flop and the sequential circuit in the block diagram of Moore circuit, and here we have also shown an example of Moore state machine where we have two flip flops along with the two combinational circuit which is connected to the input and the output of the flip flops. So, here if we look at the output, then the output expression is y is equal to q a plus q b prime, and this tells us that it is independent of the input a. And once we know the circuit, from here we can get the state machine which is shown in this slide, which has 4 states 0 0 0 1 1 0 and 1 1. So, once we get the state diagram, we can try to reduce the state diagram further by using the knowledge that we discussed in the previous slide. So, if we have initially the state diagram that is shown at the right hand side top of this slide, then we need to change that, and for satisfying the Moore state machine or representing the Moore state machine as assigned by Moore. So, here the changes are the output in the 0 by 0, 1 by 0, 0 by 1 and so on should go inside the bubble such as shown in the diagram of this slide at the bottom right hand side, and this particular state diagram represents the state diagram for a Moore state machine. Similarly, we can discuss about Mealy state machine, and the block diagram for Mealy state machine is shown here. We have the flip flops, and the input and the outputs of the flip flop are connected to the combinational logic circuit, and the input is also connected in such a way that the output is dependent on the input as well. So, the circuit of previous example can be modified in such a way that the output y will be equal to q a plus q b prime plus y. So, if we are implementing the same logic, then the number of state required is less in Mealy circuit than Moore circuit. So, both the circuits have their own benefits. Next, we will discuss clocked sequential circuit, and for that let us analyze by using a D flip flop, and let us consider the following example where we have considered two D flip flop with a set of combinational circuit which is connected to the input and output of the two flip flop. First, find the input and output equations from the logic circuit given for the clocked sequential circuit. So, here in this example, the input equation is for dA and dB. So, for dA the expression is x dot qa plus qb, and for dB the expression is qb dot qa bar. Similarly, for output the expression is y is equal to x dot qa plus x prime dot qb prime. Once we know the expression, then we can find out the state table. So, here in this slide we have shown the corresponding state table that is obtained by following the expressions. Then follow the input and output equation to find out Q A dagger, Q B dagger and Y. Once we know that, then we have to find out the state diagram from the state table. Since there are 2 flip flops, so there are 4 states, that is 0 0 0 1 1 0 1 1, which can be assigned as S0, S1, S2 and S3. Note that if the output combinational circuit is not present, then we do not need to find out the output equation. For example, if JK flip flop is used, the output is from QA and QB. So, viewers, today whatever we discussed can be summarized by the following few important points. So, we started the discussion with the concept of state table and state diagram and why they are important, what is the analogy with the truth table. Then we discussed the difference between truth table, characteristic table and excitation table, and we discussed that they can be used interchangeably depending on what we expect from the sequential circuit. Then we discussed the procedure for state reduction and the importance of state assignment. And once we knew these concepts, we tried to design some sequential circuit by following step by step the rules involved to design the sequential circuit. Then we discussed 2 important type of state machine, that is Mealy state machine and Moore state machine, and how they are different from each other. And finally, we discussed about clocked sequential circuit. So, viewers, today whatever we discussed will be helpful in designing a sequential circuit which will be optimized for our application. And I hope you would have liked today's discussion. Thank you very much.